Oh my goodness! Is this acid rain? Do you guys even know the dangers of acid rain? Oh my goodness. We need to stop this. But first, we must understand acid rain. The first thing to know is that acid rain and acid deposition are not the same thing, although they do have a lot to do with each other. Acid rain is rainfall that has been made sufficiently acidified due to it reacting with sulfur and nitrogen oxides polluting the air. Acid deposition, on the other hand, is when acidic or acid-forming pollutants in the atmosphere deposit on the surface of our Earth. It's important to note, however, that acid deposition can occur not only in the form of rain, but also in snow and sleet. As mentioned earlier, rain can become acidic due to it reacting with either sulfur oxides or nitrogen oxides, or both, of course. But the question is, how do these oxides even get into our air in the first place? Compounds containing sulfur are naturally present in soil. Plants take up these compounds because they need the sulfur to grow and live. When these compounds are taken up, the sulfur atoms bond with the carbon atoms. Once the plants die, they are turned into either coal or oil through a process that takes millions of years, and these are what we use today as fossil fuels. When fossil fuels are burned in oxygen, which is something we humans really like doing, the sulfur atoms bond with the oxygen to form sulfur dioxide, and this is released into the air. This sulfur oxide is further transformed into another oxide by reacting with oxygen gas and becoming sulfur trioxide. This substance now reacts with our normal rain to form either sulfuric acid or sulfurous acid. Now, how does the nitric acid get into our rain? Well, in the high temperatures present inside combustion engines, atmospheric nitrogen and oxygen gas can react to form nitrogen monoxide. This newly formed product is released in the exhaust and reacts with oxygen gas once again to form nitrogen dioxide. This NO2 can either react with a free radical or with the rain itself or with the rain and oxygen gas. And as you can see on the screen, all produce nitric acid. When either of these acids are dissolved in the rain's pH falls below 5.6 and we consider it acid rain. The reason we do not consider it acid rain when the pH is between 5.6 and 7 is because rain is already slightly acidic due to the fact that CO2 dissolves in the rain to form carbonic acid, which is a weak acid. The thing is, this creation of acid rain has many negative consequences. Acid rain erodes stone, brick, and concrete buildings, as well as various metals and metal alloys such as bronze and copper. Many buildings, monuments, and statues are made from these materials, and acid rain is simply eroding them and destroying them. Acid rain is also very harmful to lakes and rivers. Many aquatic species cannot survive in water below a pH of 5. Another way acid rain is harmful is by displacing essential metal ions in soil. When the acid rain falls, all the H+ ions go into the soil and force all the metal ions already present to wash away deeper into the ground, which means the roots of the plants can no longer absorb these essential ions. Finally, we humans are harmed as well. Acid rain can cause respiratory illnesses such as asthma and even chronic bronchitis. However, peeps, we chemists can stop this through pre- and post-combustion methods. One pre-combustion method we can partake in is hydrodesulfurization, where crude oil is heated with hydrogen to produce hydrogen sulfide, which we can remove by bubbling it through an alkaline solution. Or we can do a post-combustion method where sulfur dioxide reacts with an alkali or base such as calcium carbonate. This produces calcium sulfate and CO2. Personally, I prefer pre-combustion, but either way, it's our duty as chemists to save not only ourselves and the plants, but also the fishies.